Welcome to this video. We're going to be talking about today this idea of like terms. Now, when adding and subtracting fractions, hopefully you remember that you can only carry out those operations when you have like fractions, which is when you have the same denominators. Remember, you need to do converting with lowest common multiples, all that kind of stuff, before you can add and subtract fractions. Well, in the same way, for algebra, you can only carry out addition and subtraction on like terms. Now, it's not necessarily anything to do with denominators, but you'll sort of see what's sort of going on. So, here's a couple of things that you need to be aware of with like terms. So, first off, like terms are terms which contain exactly the same variables regardless of their order. Okay, so 4x and 13x are like terms because they both have just x. Okay, their variables are just x, they are like terms. 2x squared and 2x are not like terms because x squared is not the same thing as x. Well, you're literally talking about completely different things. Okay, it would be the same thing as trying to say that the number 5 was the same as the number 3. Okay, x squared is not the same as x, so these two here are not like terms. Okay, now 6abc over d and 20cab over d are like terms, okay, because abc over d is the same as cab over d. Alright, there's a little bit of a reason for that. Remember, so let's just sort of come over here for a sec. Remember that 2 times 3 times 4 is 24, and 4 times 2 times 3 is also 24. So with multiplication, you can sort of switch things around, okay? So our A, B, and C, doesn't matter what order we have on the top here, they're still the same thing, okay? So that means these two exactly the same types of term, so they are considered like terms. Now, like terms in an expression can be simplified by carrying out the appropriate operation, i.e., that is to say adding or subtracting their coefficients, okay? That's the important part. We just add and subtract their coefficients only, okay? Unlike terms, as I've said before, cannot, under any circumstances, be simplified. Just don't even try. Don't even try to add together two unlike terms, okay? Right, we're going to have a look at a couple of examples. Usually when you're dealing with like terms, it'll say things like simplify the expression 4x plus 5x. Now, I'm just going to draw a little drawing to maybe show you what that kind of is going to look like. So let's just say we had some box here and another one. Right. Get my drawing tool back. Now, let's just say that this width here was x, okay? And this is length 5, and oh, maybe make that 4, and this is length 5. Okay, so you can kind of see that we can sort of put these two things together and sort of join them here to figure out how much is this all together. So if this is 4 lots of x, okay, so this is 4x here, and this is 5x, if we add them together, what would we get? Well, unsurprisingly, we're going to get 4 plus 5, all of this together equals a big block of 9x, okay? And we can kind of see that by, instead of having to draw this drawing, you might just go 4x plus 5x simply equals 4 plus 5 is 9x, okay? That's how we do that. Remember with these ones here to write your x in that kind of cursive weird way. You can either do two intersecting or two touching semicircles like that, or you can do something like that. Is fine as well, just as long as you're able to differentiate it between the multiplication sign, although in algebra you won't use the multiplication sign very much at all. Okay, another simplification. So simplify the expression 6y plus 3x, sorry, 6y take 3x take 5y plus y squared. Now, I've deliberately sort of written this all over the place. Please don't get worried about how complicated these things might look. Really, you're not being asked to do anything very difficult with it at all. It's essentially the same as difficult, or even easier actually, as adding fractions together. Okay, so but the first thing to do when we're solving one of these is we do something called collect the like terms. Okay, so if we have our 6y minus 3x minus 5y plus y squared, okay, and to collect the like terms means to get all the like terms and put them together. Now let's have a look at what we've got here. Okay, 6y, right, we have a y here and x here, they are not like terms. A y and a y, those two here, this one and this one, are like terms. And y squared is not a like term with any of them either. So what we do is we want to rearrange this expression so that our terms with the y variable are together. So remember, and I really think that you should start to look at your algebra like this. Okay, so that is a separate term, this is a term. Remember that the operator, this subtraction sign, belongs to this one here. Same as that subtraction one belongs to this one here. And that addition belongs to that one there. So when we rearrange it, we can put these in any order now. You may have learned earlier that subtraction is not commutative. You can't move it around. Well, if you're careful about it, you can. So what we can do here is that we can just switch these two here around and rewrite this as 6y take 5y take 3x plus y squared. Now, we can carry out this part here. This one here we can do. We can't do anything with this or this, okay? So, 6 lots of y minus 5 lots of y is 6 take 5 is 1y take 3x plus y squared. Okay, remembering that if we have a coefficient of 1, we can just simply write that as y take 3x plus y squared. Okay, so that is what you would be called like simplifying the expression. So we've collected like terms here. Then I guess this second step that probably should have written in, this second step in here is we're going to call that carry out operations. Okay, so we collect the like terms, then carry out the relevant operations. Okay, final one, deliberately made it look a little bit gross. To simplify the expression, 11xyz plus 9xy squared z plus take 5zyx plus 44f. Okay, it's completely irrelevant what the variables actually equate to or what number they are. It doesn't matter. That's the sort of thing with algebra. It's generalized. It's been made abstract. You can do stuff with it that works all of the time. Okay. So what we'll do here is our first step is that we'll collect like terms. So we have 11xyz plus 9xy squared z take 5zyx plus 44f. Okay, now if we have a look at this, remember that the only thing that we worry about with like terms is that they have exactly the same letters in it. Okay, so this one here has an x, a y, and a z. This was an x, a y squared, and a z. So that doesn't have a like term. This is not a like term. Take 5zyx. Well, we have x, y, z, and zyx. So these ones are like terms. And there wasn't an f in there anyway, so that's gone too. So we rearrange, we collect our like terms. Remember that this subtraction sign belongs to that 5zyx. And we'll have 11xyz take 5. We can rewrite this in the same way. Usually they go alphabetically. xyz plus 9xy squared z plus 44f. Okay, 11 minus 5 is 6. So we have 6xyz plus 9. Sorry, that was collecting. Now we're on to part 2, operating. 6xyz plus 9xy squared z plus 44f. Okay, and we're done. Right, that's all the simplifying you can do. Don't look at that and think maybe there's something I can do with that y squared, the term with the y squared in it to get it to work. No. No. All right, just leave it alone and everything will be okay. All right. So, I hope you understood that one. If you've got anything extra that you need to ask, make sure you bring along to class to be able to talk about it. Otherwise, maybe have a go at the relevant chapter in the textbook. Okay, thank you.